Hello again. Glad you can make it back for part 2 of our notes on the electromagnetic spectrum. So this is officially your last video you have to watch until after spring break. You can do a little happy dance right now if you want. I'm really excited to do a lab and have you watch a video in class tomorrow to explain this a little better and just to give you a better visual of what all these different types of waves are. So we left off at infrared rays, which is just below what we can see, the color red. So now let's pick up with visible light. So you're going to use this as your title right here. So this is a shorter wavelength that has a higher frequency than infrared, and you can see these. That's what the word visible means. The longest wavelength that we can see is red, and the shortest wavelength that we can see is violet. And so I drew this picture on the board in class, which is to remind you of the different parts of the rainbow, so you can just imagine that the longest part of the rainbow that bends the least is the red color, and the shortest part that bends the most is the violet color. And you can kind of see this in this picture here in terms of how flexible these waves appear when they are spread out or smushed together. And you can even see the infrared just below the color red, and you can see what's coming up next in ultraviolet. So the primary colors, Mrs. Harris would be really excited to know that you guys have heard about primary colors, but I'm not sure you've talked about the primary colors of light. The primary colors of light, so if I had 3 flashlights that had like saran wrap or cellophane that has a specific color, and we shine these lights on the wall, the 3 colors that we use to make any other colors are actually red, blue, and green. You may have heard about pigment, which we'll talk about in a few minutes, but in terms of what colors we put together, it's red, blue, and green. So you may have noticed before, if any of you have messed around with the coloring on your computer monitor, or I don't know if anybody has an older TV that isn't a flat screen, but one of the older sets that actually kind of curves out. Don't really recommend looking at the screen too closely for a long time, but I remember, again, being a kid and sitting close to the TV, and if you look close enough, you can actually see all the little dots, or the pixels, were actually all these different combinations of the red, blue, and green, which is really interesting. So when you put all 3 together in equal amounts, you actually end up with white light. And you can see this here in the middle of this picture, and what it looks like to combine the red and green, and the blue and green, and the blue and red, which is pretty interesting. And I'm hoping to try this out in class in the next couple of days to show you that this is not just a picture that was drawn on the internet, but it actually happens. So the color of an object that you see is actually the color of light that it reflects back to your eyes. All other colors, if you have a white light shining on it, say a light from a flashlight or a light bulb, fluorescent light overhead, that's actually white light, okay? And so whatever is reflected back to your eyes is the color that you see. Everything else is absorbed into the object, and that's something that you don't see. Now, pigments are things that you would have talked about in art class. So those involve paints or crayons, any type of color that you're adding to a substance. These primary colors are going to be your reds and yellows and blues. And we've got our combination over here for you to be reminded of things that you learned in kindergarten. As we add more colors or fewer colors, it'll affect how much light is reflected or absorbed. So when we have all colors reflected back to us by the object, we'll see the color white. If all the colors are absorbed, we see black. And if you think about it, just think about outer space. If there's no light in space, then what color is it? Hopefully you said black. So the more light that is gathered into an area, the brighter it's going to be and the whiter it's going to be. Now, if we have red, yellow, and blue pigment, paint, and we combine them all together, we end up getting darker colors, and the more we put in there, the closer to black it's going to get. So now we're moving on past what we can see and moving to the ultraviolet rays. Now, ultra means above, and then obviously violet there. So this is above what we can see, just above it. Now, it has a shorter wavelength and greater frequency than visible light. It literally means above violet, and these are used to damage or kill living cells. So these are, things that are in the sunlight that are coming down. And if you don't have any sunscreen on, these are the types of waves that are really going to damage your skin. And it's what causes us to have sunburn. A lot of times people are excited to get tans in the spring and summertime, but if you are around these rays way too much, then it can cause skin cancer and can also damage your eyes. So if any of you have ever, hopefully not because you're too young, done a tanning bed, you might have put the little goggles that kind of make you look like you have bug eyes on, because people who are running the tanning salon want to make sure that you don't get damage to the eyes, because it's a lot of focused UV rays that are going into your skin. So that's why if a person does go to a tanning bed, they're only allowed to lay in that bed for about 5 minutes. But I'll tell you from personal experience, it feels like being in a coffin, and I wouldn't recommend it. One thing that's interesting, we said earlier that snakes can see infrared rays. Well, bees can see UV rays, and I found this really cool website that I'm going to show you in class that has a UV filter put over a camera. So a photographer has taken pictures of these different flowers, like dandelions, daisies, so common flowers that you've seen all over the place. And they've taken a UV filter and put it over the camera, so the lens is looking through a filter that allows the UV rays to be detected by the camera. And what's really cool is this camera lets you see what the bees see when they look at those flowers. And I'm not going to say too much about it because I want there to be kind of a surprise, but I think you're going to be kind of shocked at what they see compared to what we see. Their color is completely different from our world, and it's amazing. So again, some uses that we can get out of ultraviolet rays. We do use very small doses of it in order to kill bacteria in hospitals, so it helps to sterilize the area. Also, small doses are good to acquire vitamin D, which is good for your strengthening of your teeth and bones. So it's good to be out in the sun and get some exercise and do activity out and outside, especially during this time of the year, but it is really important to wear sunscreen too. I really have to emphasize that because my dad has had some skin cancers removed from his face, and it's just not fun. It's not pleasant, and he has had some scars on his face, and he has told me before that I need to be sure I wear my sunscreen, and I'm passing off that wisdom to you. If you have any younger siblings, or I know some of you even have nieces and nephews, you may have heard about something called jaundice, and this is when a baby is just a couple of days old and their skin kind of takes on this orange color or a yellowish color. And what they end up doing before the baby is allowed to go home is in the little, I don't even know what it's called, the little crib at the hospital, they'll put this little tiny fluorescent light over top of the crib in order to allow the baby to get some exposure to this type of light before it goes out into the sun, and it allows the skin coloring to develop and adjust to the outside world, and its skin will go back to its normal tone. My niece actually had to do this when she was first born, and she had to spend a couple of extra days in the hospital. We've already discussed tanning beds, so again, I don't recommend it. It's not a fun experience, and it's also not a good habit to get into. Pretty expensive. All right, next up on our list is X-rays. These have a shorter wavelength and greater frequency than ultraviolet rays, and these can penetrate most objects but dense bone and lead. So I think pretty much all of us have probably gotten an X-ray at some point in our lives, whether it's been to the dentist or if any of you have broken bones. When you are taken into the room to get an X-ray, it's localized. That means that it's kind of focused on one point in your body, and the rest of the body is often covered up in some kind of lead vest or covering that keeps you protected from being overexposed, because being around X-rays a lot could lead to having cancer. And this is why the technician that runs the X-rays will often either leave the room or they'll go stand behind a wall or a barricade that will keep them protected from any X-rays that are moving around the room. So these are used in buildings to find cracks in the foundation, so construction workers can go in and fix any kind of thing that is compromising the safety of the building. And again, it's also used to make pictures of bones, so that would be the thing that you're most familiar with. Finally, gamma rays are the last in our spectrum. These have the shortest wavelength of all, and they have the greatest frequency. And because they have the greatest frequency, it means they have the most energy. This means that they're the most penetrating. They can get through pretty much anything. Objects in space give off gamma rays, but our atmosphere does protect us against them. So this picture on the right shows us what the moon and the night sky could look like if we could see gamma rays, which, again, I'm kind of glad I don't see in that because that looks kind of scary. If we use gamma rays, a lot of times it's used in medicine to kill cancer cells, and it could be used to examine the body's internal structure. So a lot of radiation therapy uses the gamma ray technology. So this is pretty much it for our notes. Hopefully you have learned a little bit of new trivia, and you're ready to come back in the class and put some of this into practice, as well as watching the video from NASA that I told you about. I'm really excited about it. I'm kind of sad I'm not going to be here to watch it with most of you. If you have any questions, I hope that you're taking the space on your notes to write down any questions you might have so we can talk about them in class. Otherwise, if I were you, I'd start studying for my test that's about sound and light, and you've got a study guide due in a couple of days too. So again, if you need any help, I'm here for you, and I hope you have a good one.